Welcome to our channel. Today we are solving a CSES problem. In this video, we'll break down the problem statement and understand what the problem is talking about, would be understanding the logic of the problem, and then would efficiently be coding it up. So without wasting time in talking too much, let's discuss and dive how this problems would actually be getting solved. So let's read the problem statement. So the problem statement is saying us we need to count the number of ones bit in the binary representation from 1 to n. Okay, so this seems like an easy problem. Let's suppose we have numbers from 1 to n. So the problem is saying for any number I, we need to count all the ones in the binary representation from 1 to I. Okay, so as see the input is the base input is given to us 7. So for 7, the numbers are 1, 2, 3, 4, 5, 6 and 7. So the binary representation 1, it would be 1 0, and then we are moving ahead to 3 4 5 6 7 1 1. 4 would be 1 0 0, 5 would be 1 0 1, 6 would be 1 1 0, and 7 would be 1 1 1. So total number of ones in this are 1 2 4 5 7 8 9 and this 12. So total 12 number of ones are there. So now we have understood the problem, and let's see how we can actually solve this and what should be the time complexity of actually solving this problem. So let's dive into it. So as we can see from the constraints, that we need to think of a logic that would be something less than O of n, because as n ranges from 10 to the power 15, so our O of n solution won't work in this case. Now what is the first approach that came into our mind? The first approach that we came into our mind is for each I from 1 to I, calculate the bit representation and calculating the ones into it. So this would be a costly operation, and it would be taking in worst case O of n time to traverse, and then finding the for each I, then we will be finding the binary representation. So this would be a time complex highly time complex case, and so it would give us a TLE solution. So as we can see, we need to optimize this. So how we can optimize this? Okay, let's think of in the lines of something if 1 to n, and we can say that how 1 to n can be related to something of n by 2. Like, can we relate first half with second half anyhow? If we could do that, then we could simply make something of f of n is some k times f of n by 2 or any operation. So then we could reduce this f of n to log n complexity, near approx to big of log n complexity, and that would be a much efficient solution, I would say. Let's see if we can find anything closely related to half of this. Okay, so let's see, let's divide n into two cases. What if n is odd and what if n is even? Let me erase this complete. Let me erase this complete for you, and we can understand this in a much cleaner manner, I would say. We could make a new page. Yeah. So let's divide our n into two cases. N is odd and n is equals to even. So let's see if we could deduce something from that. Let's see if when n is equals to 7, so it would be 1 2 3 4 5 6 and 7. Now if we think of their binary representations of, let's suppose the binary representation of 1 is 1, 2 is 1 0, and 3 is 1 1, 4 is 1 0 0, 5 is 101, 6 is 1 1 0, and 7 is 1 1 1. So can we think of some pattern into this? Are we able to see any pattern that we could recognize from it. So as we can see from here, we can say that every n by 2 plus 1 to n, if this half we are talking about is exactly the same binary rep of binary rep binary representation of 1 to n by 2, just with extra 1. Can we see? Let's see if we have this. If we go and understand this part, so isn't it something like 0, 1, 2 and 3? So, and we have 1, 2, 3 already been calculated. So we can say that if we know the answer to this particular solution, then we could add all these n by 2 extra ones that are in there in the second half, and then we could finally get the answer. So this is what we would be using to deduce our expression. So let's suppose for finding the solution for 1 to n by 2, let's take it as a floor value. So let's suppose this is f of n by 2. Okay, so how would our second half of n by 2 plus 1 till n would look like? So it would be something like f of n minus n by 2 minus 1, which would eventually be f of n by 2, as n is odd, because obviously we can calculate this and this. So our f of n would end up getting into twice of f of n by 2 plus n by 2 plus 1. So this n by 2 plus 1 is the extra 1 bits that we are getting from n by 2 plus 1 to n. So for odd case, when n is odd, when n is equals to odd, we can say our expression would be f of n equal to twice of f of n by 2 plus n by 2 plus 1. So this is our expression for when n is equals to odd. Now let's see what if our n is even. Now if n is even, let's see can we deduce something when our n is going to be even. Okay, let's analyze this with a, because n is equals to even is a tricky case. Let's analyze this with a example. Let's suppose n is equals to 6 in this case. So we'll divide it into 1, 2, 3, 4, 5 and 6. Binary rep would look like 1, okay, 1 0 1 1 0 0 101 and 110. So if we analyze this thing, let's suppose let us see and divide it into, okay, so let's go and see this part, 4 5 6 part. So in this 4 5 6 part, can we think of this as where we are getting extra ones bit in this? So this would be 0, this would be 1 and this would be 2. So isn't it n plus 1, n by 2 plus 1 would be dependent upon n by 2 minus 1? Like if we know the solution to 1 to n by 2 minus 1, f of n by 2 minus 1, and then we can find the solution to this complete part by just adding these extra ones bits. So just a small change in n when n is equals to 1's case, it would just land up in the case of our equation would something look like, okay. So let's see how our equation would look like in this case. It would be like f of n is equals to f of n by 2 minus 1 plus f of n by 2 plus n by 2, as these are n by 2 extra bits that we would be counting. So this is how our equation for f of n when n is equals to even would look like. Now let's finally get our equation if n is odd, our equation would look like f of n is twice of f of n by 2 plus n by 2 plus 1, and if n is even, it would look like f of n is equals to f of n by 2 minus 1 plus f of n by 2 plus n by 2. So this is how our final equations would be looking like. Now it is easy to code. We would just be using a DP array, or we could say a recursive solution, and then a DP in that way, and using a storing value in a DP map to get our solution into log n. But we need to take care of one thing in it. As n is tending to 10 raised to power 15, we cannot use a vector or an array in this, because that would give us a MLE, memory limit exception kind of thing, or a space issue would come. So in this case we have to use a map. So let's see how we can code up the solution. Okay, so let's move. So this is the IDE I'm writing the code in C++. So let's see how we can code it up. So our input, we can see our input is a single integer n. So input n, c in n, and let us define a function f. Int function calculate, and it would be taking two things. One would be int n, and let's suppose it's int v and okay. And now let's take a map. We'll define the map below. This the reason behind using a map is to just avoid the recursion, like not exactly recursion, but just a recursive calls, I would say. Unnecessary recursive calls. If we directly get the solution for a problem that we have got already stored, then we could directly be using that. So yeah, all set up. Now let's write the code for it. So base case would be if v is equals to 0, then we would be return 0, obviously, because there would be no case for that. Now if our dp value already has a value v, like we already have a value for that in our store, then we would directly return the value for that. Now let's check for even. So if our v and 1, this would return a dp v, which would be equal to twice of calculate n by 2 comma dp plus, this is a case for odd, plus n v by 2 plus 1. Now in else condition it would be near the same, just the function call would be changing. So it would be calculate n by 2 minus 1 comma dp, and also plus n by 2 comma dp and b2. So let's test our solution. Yeah, so there are some compilation error. Okay, so we have written n by 2, it would be v by 2. Yeah, I guess we are all set. So our test case for a base test cases first. Let's make another test case that we should test. I guess let's go for 9. Let's go for 9. For 9, the answer should be 15. Let's test if we are getting the correct answer. Yeah, we are getting the correct answer. Now let's try to submit this problem. This would be main.cpp, and it would be this. Let's see if we got the solution for this. Yeah, our solution is accepted, and it's correctly accepted. So this is how we solve this problem. And for any, I hope you all have got how we have solved this problem. It's a good problem, as we have to think a lot in it. because how we could think of in a n or an n by 2 approach. See you in next video, and please like, share and subscribe for more such videos, and would be coming more such videos on CSES problem set, and I would be making a playlist on it to get you guys help in it how we solve the problems. Thank you.